small hick. Can start off with some icebreaker. So our agenda for the day is we'll start off with an icebreaker. Then we get into the session. Then we have questions afterwards. So just to start us off, who may know about Git or who knows what Git is? You can just unmute, introduce yourself, and say something. Or if you have an idea about Git.
It's a version control system.
Pardon, I can't hear you. Somebody is speaking.
It's a version control system.
Okay, nice. Anybody else? Just one person or two.
Hi guys, good evening. I can give a try.
Okay, thank you.
Yes, so Git is a version control system that tracks changes in a set of computer files, or the files that mostly it's program files.
Thank you. One last person. One last person. Okay, so I guess we can leave it at that. Okay, so as as it has been mentioned, Git is a version control system to track changes during development. So as simple as that, So much will be covered by Anthony. So I'd like to welcome Anthony to take over from there. Anthony, are you around?
Yes, Dan. Thank you. You can hear me?
Yes, we can hear you.
All right, let me share my screen quickly.
Okay.
Oh, okay. So let me, you can see my screen?
Yes, I can see it.
Okay, just a minute. Let me hit this. Yeah, but as I just set up everything here, as you've heard, my name is Anthony Nandaa. I'm really glad to be part of this community. I'm actually a member of this community. I'm always just silent in the WhatsApp group, but I've been following what you guys have been doing. So I'm part of you, basically. Yeah, so I'm really glad to be here today with you, and hopefully we'll be able to learn one or two things together today about Git. Maybe as way of introduction, I'm a software engineer. I don't like mentioning where I work. but it was already mentioned. But I just like always to be judged by my character rather than the character of my employer. Okay. So I've been in the community, especially like doing these community events for quite a long time. Like I started off with this community work in 2012 with GDG. That time it was called GTAG, Google Technology User Groups, and the rest is history. So today, as you heard, we'll be looking at Git, the internals. But before I start on Git, I wanted to know, just by show of hands, don't be afraid if you haven't used Git before. Just raise your hand if you haven't, because I'm okay with doing a bit of a quick primer on just the basics of Git, and then we jump into the internals. So it will be of no use if we talk about the internals and we don't have the basics. But all I need is just, if you've ever used Git basics, don't have to have the like superpower or power user kind of Git. Okay. So okay, yeah. Thank you so much for your honesty, because this is really good for me. I just need even just one person. I'll still be okay. So nice. So I'll quickly then I'll just do a recap of just Git in general. But as people had mentioned, Git basically is a version control system, and basically what you want is you make a change today in a particular file in your code. Most times it's code, and then you can be able to revert back to the previous change. You can be able to do a branch and start over a new sort of idea and then merge it together later on. So basically, you'll maintain, before Git, most times people like myself, I will use just like I remember my project, my fourth year project, I was just doing, I was just saving my projects in a folder, zip, and just zip it and then upload it on Google Drive. That time I didn't know how to use Git, by the way. Honestly, Git was there, but I didn't know how to use it. And but it was a bit long time ago. Very few resources were around also. I think GitHub it just also maybe started maybe like 2 years ago, something like that. Yeah. So, but Git has been there for quite a long time. But GitHub helps to bring Git, basically democratize Git, because now you could save, other than just version controlling your thing within your machine, because your machine also could crash any day and you lose everything. With GitHub, now you have a place where you can store on the cloud your repositories, and then you can be able to access them anywhere. You can share with other people. So GitHub really helped, and then of course GitLab started later on. I think recently. So for just a quick primer of Git, I'll be using. I know most of you guys are on on the Ubuntu or the Mac, so I'll just use WSL for now. It's on Windows, it's the same thing, but it makes more sense with Linux, because it was actually, that's how it started. It was built by Linus Torvald, who is the author of Linux, the original author of Linux. So let's just do a quick recap of how Git works. So you have a project, you want to start a project. I'll just call it, I think I had a folder here, I'll just a directory here that I can work from. I think it was play Git internals. Yes, okay, good. So I'll just create a folder called primer. So you start off by, either you have a project already if you already have a project, let's say you have a project that has a directory called primer. So let's make a directory called primer here.
Hi, Anthony. I think
Yes.
you're not sharing your screen.
Oops. Oh, this time I knew I was sharing. Thank you for that. So sorry, I stopped sharing and then I forgot to share back. I'm sorry. Yeah, but there's nothing more. I've just been talking actually. So yeah, here we go. You can see my screen, right?
Yes, we can.
So what I did, I just went to WSL for the guys maybe on Windows who are wondering, like if you're on Windows, you can use Windows still. It's totally fine. But I think I was trying to cater for most of the people here. I think once you're on the DevOps side, I think most times you'll work with the Linux distro. So I just did WSL. So this is a nice feature that was added on Windows where you can run Linux within Windows. So Linux actually runs here like a quote unquote an app. It's not really a VM. So okay, sorry, now it's a VM. Kitambo, it used to be an app. Okay, so right now I have I've created a folder called primer here. Okay, so I'm assuming this already was your work was already in this directory. Okay, so the first thing you want to do is to you git init. So with this, basically is the initial, like basically you're making now this directory a Git repository. And the only thing that will change here, if you do a less, there's nothing. You can see it's just plain. But if I do a less this, I'll see that there's a .git file, .git folder that was added. Sorry, I keep using the word folder because I'm from Windows. I work on Windows a lot. But the right name is directory. So if you hear me saying folder, directory, just replace. But the right name is directory. So there's a directory here, which is .git, and that's the one that actually stores everything that we are going to look in. So this is going to be the main point of discussion today. But for the guys, just to catch you up on Git, the first command is git init. You initialize the repository. Now it's a repository. You can do things like git status. It will tell you it says no commit on master branch, no commit yet. Okay, so you can create let's say there was a file here. I'll just do attach instead of putting stuff in. I'll just do attach. I say sample dot. Let's say assume it's JS. Attach another .js. Okay, so you have these two files that you've created in this directory. So if you do git status, you see that it will tell you that you have untracked files. So basically these files you've created them, but they're not being tracked by Git, because Git is tracking, as I say, version control. So it tracks the versions of your files across a time period. So the next thing will be to stage these files. So remember the commands are just git init, git status, git, and then the next one that I'm going to show you is git add. So git add, you can specify the file that you want to add, but if you're sure that everything here, you want to add everything that is here, you can just say all, okay? So it's -a stands for all. So if I do another git status, this git status, you keep using it a lot. You see that the files have changed the color even. It shows that they're now staged. They're ready now for committing. So stage like just they thought of before just committing directly, they give you a chance to, because once you commit, actually it's a very, as you'll see in the internals, once you commit something, it gets into the database and you cannot remove it. Yeah, so the staging area was just meant for the purpose of you being sure that, okay, I have everything here. And by there, I'll come back to that point of you can never remove it once you're committed. That's why, like for you guys who are, because I'm just addressing you as all of us are DevOps guys, as opposed to maybe sometimes some of us are not DevOps, but you'll always come across this thing of, by mistake, someone has committed a secret file, maybe a file with passwords or a file with or with API keys. So that file, once it's committed, and if it's in a public repository, basically the only thing you can do is is delete that repository, because basically as you'll see, everything will be in the database. Even if you go back and do a git, we'll try and do all these things like git reset, hard, go back in history. You might think that you cannot see the file that you committed there on your tree, but it's actually in the database. You will see it as as we go into the internals. Now, the next command. So just recap: we did git init to initialize the repository. Then we did git. We created our files, and then there's git status. Anytime you can call this git status anytime. You just see how your repository is doing, what's the state of your repository. And then now we did a git add where now we are staging everything. This is staging. Now the next command I'm going to show you is now you've staged, now you want to commit. So git commit. So this is kind of like saving now. You're saving this work now in the database, because take git as a database of this stuff. But as you see in the internals, it will just be, they're just files, they're just simple files that are used to track all these changes. So git commit, you give a message. So I can give like an initial setup, my project. Okay. And now you see these files have been committed, and now we are good. Okay. So if you do git status, you'll see that there's nothing else to do. Your branches go, nothing to commit, and everything is good. You can do git log. So this is the last command I think I'm going to show you for just the primer for the guys who didn't know about git. So git log, we can see now the log of things that you've done. I could maybe go into one file and change it. So let's say I do echo console.log hello. Okay, so I'm assuming this is my JS code I've added in another. What is that file? I think I misspelled it, but it's another. Okay, so I put that in the another, then I do git status. Okay, I promise this was the last command, but the one last one is git diff. Okay, git diff. So if you're taking notes, you can just check that. So git diff, you can see the differences of what has changed since the last commit. You can see that the only thing has changed that is I've added this file. If I add another thing, let me say I do another. I add also this another to the first file. What is the name of the first file? It was sample. So if I add this to sample, I might change it a bit for hello. Okay, and I do git status. You can see that it will tell you what really happened there. Or git so no, not really setup, but git diff. Sorry, git diff. So git diff, you can see the change. Another has this change, and sample has this change. Okay, those are and plus means that you've added. Minus is you've deleted some lines in that code. So now it's time to commit. So the first thing is first to stage it. So because they're both of them, just add all of them and then commit. Give a message. Normally, again, there's it's a rule of thumb. Now, this I'm not showing the best practice. The best practice is make sure that the commit message is descriptive about what you're doing. Now, let's say if this is a change, so I could say maybe first lines of code, but this should never be a commit message, because if it's first lines of code, everyone can see it's first lines of code. But what were you doing? So it could be like maybe you have you finished a particular maybe milestone, Okay, now authentication done or something, whatever the feature that you've finished, you could be a commit message. And then even it's better to have even a more descriptive commit message. You have the first line and then you have the body with the description. But I won't go into those details. So at the end of this talk, I have a book that I recommend, but also online there's so many resources that you can get for Git. And also I like using if you go Google just any cheat sheets, you can get some cheat sheet for Git that should always be somewhere in your corner of your files where you can look. Sometimes you forget a command, maybe rebasing, for example, is what I always forget. For example, I want to edit some commit messages that were like maybe 2 histories or 3 histories behind, or squashing commits. Sometimes those things that I don't just remember them off it, so I have to go like in a cheat sheet and check. So yeah. So now git log, you can see that there will be 2 things now. You had the initial setup and then the first lines of code, which I said all these are very bad commit messages, but this was just for the sake of explanation. Yes, I'm hoping that for the folks who raised their hands, I'm just hoping that this maybe has shed some light. But if you have any question, let me know. Are we good? I think I saw like Njogu. Anyone, just tell me if this is making sense. Then we can go into the internals work now. Okay, thank you. I see a thumbs up. I appreciate it. So good. So let's go to the main thing of today. Okay. So today we want to talk about Git internals. Now all this that you are seeing, what's really happening under the hood? You want to go check and see, like, I see her hand raised. Yeah, go ahead. Keith.
Hello, and thank you.
Thanks, Keith. You go ahead. I hear you.
I have a question concerning the command for git add.
Yes.
There's that git add that you've put git add then -a. What's the difference
Yes.
between now from it with the git add? Then there's usually a space and a full stop.
Oh, very good question. So I like that. So that one will be, so let me give you an example. I'll use an example here. I'll touch another file here. Just say touch Git, now that you're the one who asked here. Okay. A file here, and I'll make a directory here and call it logs, for example, and then I'll make another file inside logs called maybe test.log. Okay.
Yeah.
So if look at this, so if you say git status, you can see that there are 2 things, that there's this and the directory, right? But if I went to the directory and now I did git add dot, it's the same as you know, now the same dot that you say, basically you're only adding this directory.
Okay.
If you look at status now, you'll see that the other kit is not added. You see kit is not added.
Mm-hmm.
Yeah, so it would be relative to wherever you are. So it could be good for sometimes. Let's say if you're working on a very huge project and you are sure that your directory is just one, maybe it's 3 levels down, and you are sure that's only your work is in that directory. You don't want to worry about the rest of the directories. You can just say dot. That would be good for that time. But if it's your project and you've done so many things in various directories here and there, you can use all. But again, now if you use dot in the root directory, it will is as good as all.
Okay.
Yeah, so dot can be equal to all only when it's in the root.
Okay.
Yeah, because now if I go back here and I do now git add dot, now it's everything. You can see that is everything will be there. Yeah, so but that's a good question.
Okay. Thank you.
Okay, good. Let me add another comment here. This is, but as I said, these are very bad commit messages. Okay. Okay. I can see git log. I have all the three commits here. Okay. Ali.
I have a question about git add also.
Mm.
I've seen git add flag p. What's usually the use case for flag p minus p?
GitHub. I haven't seen that before, but I can check. Help. You can do any git command. You can just add dash help. Normally, the problem it doesn't not really. It doesn't show you the help. Oh, no, it shows. Oh, it shows the help. I thought it will open the online. Sometimes I think only on Windows. I think, but here you can see. You can go check what P does. Yeah, P patch. Yeah, interactively choose chunks of patch between the index and the work tree and add them to the. Also, this one you get into an interactive. Interactive shell where now you'll be choosing whichever things that you want to add. Let's say you have so much, like you don't want to go now trying to type every file. Maybe you have 10 directories, each directory has 2 files that you're interested in or something like that. Yeah. So yeah, those are the ones that maybe you rarely come up, you like use them, but they are really helpful whenever like people who are working on large projects. Because first Git was built for like the Linux project, the Linux kernel. So it has so many submodules and various maintainers working on various modules and all that. So when and again in Linux, you don't just do a pull request, you have to send the patch as an email. So usually you send your code as an email, but a patch. Not just you don't copy paste in the body of the code, but rather you create a patch and send that patch. So with those kinds of patches, you need now this kind of like advanced commands. So Git has a lot actually. Git, but if you just know about like 20% of Git, you're just effective in your typical day work. Good question. I didn't know even about the P, so it's good I've learned something today also. Keith, your hand still raised. Any other question? Oh, so okay, good. Okay, now we are done. So that is out of the way. So let's go back now to the main thing. So Git internals. I'm just calling this part 1 because it's this talk is based on a book. There's a book that I'm going to recommend. It's called Pro Git. It's right here. Pro Git, but I'll send the links. Yeah, this is the book. But I'll send the links right after this call. Also on the WhatsApp. I can also say it on the WhatsApp. So, but this is the main book. So this one I just saw it today. Someone recommended, but I haven't looked at it. But it ended up being like the guy who wrote it also is the author of the other book. So it's interesting. But I noticed that the approach in this new one that he did, that it's an old book. It's like 15 years old, I think. Yeah. So this one by Scott is it Chacon? I don't know how to spell that, to pronounce that name. Yeah, but there's a topic in that book called Git internals, which most of this material that I'm going to share with you, it's motivated from there. So So why I'm calling it part one is because basically this is the outline of that chapter. Most of the things I'm not going to cover for today because of also time, and also not just to bore you with so much stuff. But my aim, as I said here, my aim is to start you off on a journey of discovering how Git works under the hood. So today, if you can just be curious to go in and check how, oh, now I know a bit at least about how Git works, and these are the foundation bits. And then Git is actually, if you at the end of the day, you'll see that Git is very simple in terms of its interface, or I don't know how to, just in terms of its design, not interface rather, but the design is very straightforward and simple. It's only that the code, of course, to bring everything that every simplicity comes with a very like a big pain of like writing very good code and making sure everything works well. Yeah. So yeah, so high level Git, we call it a version control system, but the right definition is like it's a content addressable file system, because everything you see it's based on a file system. Because if you just say something is a version control system, even on Google Docs, there's a version control. You can see, you can go back to versions there. It can be very vague if you just say something is a version control system, but it's a content addressable file system. You see that everything that runs Git really depends on those files. Every stuff there is in the file. So actually, a simple thing is this: we'll do something here with you guys and see. You see these are the files that are here. I could delete all these files. And sample plus the logs. You want to you can delete these files, but they're not really deleted. Or another way to put it is, if I just gave you the .git directory alone, if I just zip this and send you an email, you can be able to reconstruct everything here. It's almost like working like a what's it called, a detective. You can walk back and get everything, and when I created it and the file, and you can reconstruct everything. So the Git directory has every information, and we're going to see it in action now. So okay, from here henceforth, I'll just use. We're going to be using the terminal. I'll be explaining many things through the terminal. But before I go there, maybe let me just check. I had my notes here. I just wanted to make sure that there is a good flow about. Yes, okay, good. Yes. So the idea is this. Let's start off again, almost like the tutorial, the way we did the primer tutorial. So I'll go back. I'll make another empty repository. Let's call it Git init, and I can just give it another name here. Let me call it Nairobi. Okay. So you can see that Nairobi is right here. Okay. So let's get into Nairobi. It's an empty, totally empty repository, but with, you can see something with a .git. This is everything now that will be that is storing our the details of our repository. Now, wants to look into the .git. So I'll open it with the Visual Studio Code. Just do code.git. Yeah, it takes a bit of time. So this is because of, it's another like operating system calling to another operating system. So it has to take a bit of some time. There's like a server that talks to this other one. It's almost like you're remoting to another machine. That's why it's taking long to open from Visual Studio Code, but will be good in a minute. So I also chose Linux. I'm running on Windows, but I chose Linux because there is something that I'll show you about Linux that Windows, about file mods. You guys know about like the mods, right up like 777, 644. So you see them in action also here. But on Windows, those file mods, they don't work. It's not Windows designed differently when it comes to file system. So here you can see that the .git direct. Now I'm not opening my project. I'm just opening the .git alone. And then I don't know if you notice that normally .git is not by default. Visual Studio does not show .git. Okay, if you just say open Nairobi alone, just say code dot alone here, it will be hidden by default. So I have to forcefully open it here so that I can see the stuff. So you can see that it has these directories, branches. So far, branches is empty. Hooks, this is another topic on its own, which is very important for the DevOps guys. If you want to like do some magic stuff with Git, like after someone has committed, you want maybe to do an extra thing. You've seen in some like the code, like Linux code, usually see something like signed off by this person on Node.js. So some of these, even Kubernetes, these projects that are big open source projects, you see that you have to have people who sign off those commits. You already do your commit, but you'll see another editing of your commit. So those are the things that you do with hooks. So hooks is not a topic for today. Hooks, it's for another day. And I would like someone maybe to pick this up and present it in our session. And then info, don't worry about this, is just extra stuff on, it's almost like the .git ignore, okay, but I have never used this one. And then now where we'll dwell a lot here today is on these two directories, objects and refs, but mainly objects. So objects is everything now. Objects is where, even if I lost, if all I had was these objects, what you call this object directory inside Git, is all that you need if you're a detective to get back everything that was happening in that system. And then again, even to make matters better, is there's another one that will appear called logs, which actually says now what followed what and what, everything that was done in that repository. So by now you can see that they're just empty. They're purely empty. Everything is empty. Head here, tags, no tags, everything empty. Okay. So let's now do something in these repositories. Okay. So we will do, I'll just be touching some files and maybe putting some stuff in. So I'll do one file called music or something like that. Okay. So I'll echo Miles Davis, one of my favorite musicians, into a file called music.txt. Okay. Now I have one file inside my Nairobi directory. Now the first thing is to already init, right? The next thing is to stage the files. So it's just one file. I can just say add music. And then now, after adding, actually, you might be able to see some changes here, but that's not really my focus for today. There is this other, you'll see some index file here. This one wasn't there. I don't know if you guys were paying some attention, you'll see that this index wasn't there until I added some stuff. Okay, so Let's open. See, it's a binary file, so you'll see some question marks and stuff. But basically, this one just tells you the file that it gives you some information about the staging area of what's happening. But that's not really my point for today. That then we can leave it. Our main aim that what I want you to pay attention at is the objects. Okay, so already there's something already that has come to the objects already. You can see here. Okay, but you're going to it. We'll go and check what was it. What was it that was here? And everything you see in objects is the hash. So everything is hashed. This is what we call. So hashing is another topic, but if this is the first time you're hearing about hashing, I'm sure you're using hashing in many things without you knowing. Whenever you want to maybe do your password and store them in a DB, you don't want to store them in plain text. You have to hash them. So hashing, there are many algorithms for hashing. There is SHA, there is MD5, which is deprecated. But the one that is used here is what we call SHA-1 for hashing here. It's almost close to MD5 because it also has about 40. It does 40 characters wide. But this is just for Git. But for security, if you want to have the best security, is of course SHA-256 or even I think SHA-512. I think out. But I'm not question mark on that. But SHA-256 is the most common for like hashing your anything that you want to be in secret. But this hashing here is for the purpose of, because this Git, as I said, is like a database. So it's key value. So for you to quickly get something, you need a unique identifier. If you had something like a directory, not really a directory, but a dictionary or a hash map, you'll need a unique identifier so that you can get whatever that you've stored. So these are the unique identifiers, because you'll never get a conflict of this, like two objects that have same hashes. Okay. So, so just hold that thought here. We're going to look into what's happening in that. But for now, I want us to do the commit, and you'll see more stuff up. Yeah, so we have staged. Let's just make sure that we have staged correctly. Everything is good. Yeah, it's right there. Now let's commit. Git commit. Edition added. Oops, there's something that I did wrong here. Okay, anyway, put two quotes, but it's good. So now we are good. So let's go back to our stuff here. You can see that the more stuff, that more 61 and all this. Now there's 61 and 0B, which is just the directories that have hashes. So let's talk about what are these hashes. Okay. So these hashes, the model that I want you to have in mind, and you're going to see all of them, is this. Let me go for you the model that I want you to. So let me just. Okay, so I was to change this way back before this call, but I think I forgot. But anyway, okay, good. Now so this is what I want you to have in your mind of the mental model. Of course, there are things that you already know by now, but there are those that maybe you haven't known, but you're going to know them in a minute. The first thing that I want is a commit. And you see it. And you see that a commit links to what you call a tree. A tree. And actually a tree can have many other trees. So there is you can do like an arrow back to it like this. And then a tree will have many trees, many other trees, but it must have at least one blob. So blob now is the actual file. So remember that musician, music.txt. So that's not really the blob, but the blob is the content of that music.txt. So this content is what now we call the blob, minus the name. Okay, very important to know that it's minus the name, and I'll explain why it's minus the name. So cats music. So this content is what now we call the blob. Miles Davis, that's that string. Miles Davis is the blob, now our blob. So far what we, so let's look at those files. Those files were inside. If I do I find into Git, okay, find all the files of type F. Okay, they're basically final files. Okay, so these were the files. If you saw in my Visual Studio Code, these were the files. So this is the thing. The whole of this is the hash, even plus the 61. So what Git does is just for the sake of organizing, because if it was just storing everything as one file, that object directory will be really big. So to make it a bit for the internal like easy matching, and also the algorithm will be easy to match you if you get everything that starts with 61, you'll just get in that directory of 61 and now search for the exact the remaining match. Okay, and then you notice that Git sometimes, because of if they're not many, you don't need to provide the whole hash. You can just provide 4. I think you've seen them with even GitHub. That's just if the project's not really huge, you just need maybe 5, just 61 C8 B4, and you get the details of that hash or that commit. But all these things are not commits. These are now the 3 things that we mentioned in our model. Okay, if you remember, we said commit links to a tree, and the tree links to a blob or many blobs. For now, first just have everything. We have one commit, and then this is the commit. But we'll go there and check exactly. And then we have one tree, and we have one blob. So let's check which one is a tree and the blob. So the best is to start with the commit. But assuming we didn't know which one was it, so let's do there's a command now here that I want you to note down. It's git. You say git cat. Okay, it's the same as cat, but now this is the cat for git. So git cat, and then you just give it the hash. So I'll give it the whole hash, but you can just take a bit of it. You don't need to give the whole of it, but let me give the whole of it for the sake of just to. It's now full. So remove. Oops. Yeah, I'm having my. Yeah, sorry. Okay, good. So here, also you have to provide -2. So there are many that 3 things, and there are more actually. T, you can get the type. P, it prints the exact things. for like printing, P, and then there is S for getting the side. So, but we'll be using T and P for the most part today. So T. Okay, I'm mixing up something here. Sorry, cat file, not git cat file. Okay, sorry. My computer is hanging a bit, but I think I know why. I'll just stop I was trying to record this also as a, it's okay. Let me just stop my recording in a minute. I think this Camtasia is the one that is overloading my machine right now. So let me just stop it. Oops, it's already 3 minutes to time. I didn't even look at my clock. Okay. So, but I'll be quick. Let me see. Yeah, I think this Camtasia was really taking a bit of the tough here, but I'll just record this another day. Okay, let me share again. Yeah, this Camtasia app is the one that is making my stuff be slow a bit, but I think by now it will be better. So cat file, that is so it's git cat file, okay? So there's something I didn't mention. So that these are what they're called plumbing commands, okay? So the most commands that we use are they're like git add, git commit, git push, git pull. So normally those commands they have other subcommands that are doing things. So cat file, you'll never use it like in any of your work, but it's string by it is used by these other commands that we use. So these are called plumbing commands. So you can see that the type here is commit. You guys can see my screen again. It's commit, right? So now let's look at the content. The content, we just put the P. You can see this is the content of the commit. And I said, remember the model, commit has tree and tree has blob. So look at this. The commit has this tree, and of course the details of the commit, who committed it, the author was Anthony Nandaa, the committer was Anthony Nandaa. Again, you know why it is this way? There is a committer and an author. It's because of the history of Git. As I said, it was used a lot and still used in Linux development of Linux kernel, and it was actually that's what was inspired by it. So normally the Linux kernel, if you're not the maintainer, you don't commit to the kernel. The maintainers are the ones who commit. So if you have a patch or something that you want to add to the Linux kernel, you will create a patch and send it to that mailing list for them specific maybe file, or if it's a file system or whatever the subsystem is for the Linux kernel, you send them that patch, and then now someone else will be the one who is committing. That's why there's a committer and there's an author. So these two things, you rarely see them in your logs. You just see the author most of the times, but the committer is also it's also a very important bit of this. So it could be another committer, but another author also. Most times it's that way actually, because many people author and then the committer, only the maintainers are the ones who commit. So let's look at now this again, the same thing. So of course, by now we know this is a tree, so you don't need to check its type. Let's just do a git cat file and look at its contents, okay? So you can see that these, basically, so think about Git this way. It's almost like actually the best way to think about, just think about a detective or someone who is trying to see about what's happening everywhere, right? So when you hear like we've done a commit, we have basically have just done a snapshot. We've taken a photo of that tree. The tree here is tree is the directory. Tree is I don't know if I have the tree command here, but tree, yes, I installed it. So if you have the tree command, is another one that can just show you your structure of your whole directory. So tree basically is the same idea. The tree is the directory structure because it's actually a tree. Yeah, a tree data structure because it has a node, a root, and then it has leaves and all that. So basically when you do a commit, it's like you're taking a photo of that tree at that particular time. So at that time when you committed, the tree only had what? Music.txt. So and that is what is written here, the blob. And then I think the guys here, you've seen that 644, this is the mod. This is the, like, if I do an ls.la here, these the exact things. So this is the, like, the mode of that file, this one. This is now the 644, okay? And then the type, of course, is a blob, and then it's hash. So you see everything, there's a hash everywhere. Hash, left, right, and center. And then the name of that file, which is the music.file. Okay, let's look at the content of this. We already know it's a blob, so just take any, even 3, 4 will be enough. I can just copy that, git that file, p, this, okay? You see, Miles Davis, the exact stuff that is in music.txt. So this is the one that is being stored. Okay, let me show you another thing. What if I had another file called jazz and I put my Miles Davis? Let's see what that happens. So echo, just the same, no like everything the same. Okay, let me just copy paste so that I make sure it's everything the same. Miles Davis, okay? Davis, and I put it in a file called jazz.txt. But I add it, add jazz, and then I git commit m. Okay, now I have this git log. I have two commits, and now let me go into this commit. Okay, and already, of course, you know by now. Let me take you back to our stuff here. By now, you know there will be more other objects that have been added here. You can see A3 and AF weren't there. So let's go and check what's really happening there. So, or if you just want to see the, I wish there was, but I didn't know that. But anyway, if you remember that command that I was using to just see the files that I've written. So that was way back, okay? It's better to type it. So find inside git objects type file, okay? So you can see, if you remember, there are not this, there were a bit fewer, right? I think there were 3. Yeah, there were 3. Remember, there was 1 tree, 1 commit, 1 blob. Now we have 2 extra stuff. One of them, of course, must be a commit. Another one must be something else. Let's go and check. So how do we know that? We can just get the last commit, which was this. This is the last. This is the commit that has the stuff. So git cat file minus p. Let's look at that commit. Sorry, oops. Okay, I pasted faster than I. Okay, good. You can see this is the commit. It has a tree. Let's look at that tree. Trees will be just the same. So okay, tree now. Now look at this tree. If you guys remember the last tree we did on this tree. So git cat file. As I said, look at the tree as something like someone has taken a photo of your directory. So you see, this time when someone takes that photo, you find there's a new file called jazz, but music is still there. Music is the same, but there's a new file called jazz. If you are careful, I don't know if you notice that the blob has the same hash. These are very important points to make. Same hash. Why? Because Git now has to be smart. Other than like if the file has same content, why should you store the file many times? So Git actually, that's why sometimes you see Git, the directory will be very small. No, in size. That .git, if you look at the size, most time it will be smaller than your real directory. One, because of such things, and two, because of it. It also has a zipping algorithm that compresses, or zlib that compresses the files. But the point here is that the hashes are the same because the content are the same. So let's look at the jazz. Okay, so jazz. So git cat file -p this, and you can see it also has Miles Davis. So what is really happening here is this. This is our model. Now this is the reality in the ground. So this is the hash. Let's look at let's just take the one that this commit. You commit nitrogen. So there's this commit. Let's take git log. Okay. So let's start with the previous commits 6168. Okay. So 61. I'll just take 6168. That was the commit. It had which tree? The tree here. Well, I will go check the tree, but there. And then, so the tree for 6168 was, no, it's sorry, it's 61C8. Sorry about that. So git that file -p this. You can see the tree was 0 BDA. Okay, so this was C. This is not. So let me just. This is C. So 0 BDA. That is the tree. The blob. The blob here is we check the tree. Okay. So tree. The blob is 9404, right? Is the blob 9404. 04. Na hii ndio the blob for Miles Davis. Miles Davis. Okay. Oops, sorry. Miles Davis, okay. And then next, what we did was the new commit, this commit now, the AFA commit. Now let's look at that commit, the AFA. AFA had another tree called A3C6. So AFA, there's new commit. So let's assume that we are going right. So this is the time. This is the time. So the next commit is AFA8, okay? A, but anyway, you get the point. Okay, that commit had a tree called A3C. This is another tree, A3C, what? A3C6. Why it's another tree is because you notice that there was a new blob that was added, new blob here that was added, that was jazz, the jazz.txt blob, right? The file rather, but the blob is the same. But now the funny bit is that this tree, as we check, let me just go back to it again. As you saw, this tree has the same blob, has two blobs, jazz and jazz and music. Okay, so okay, maybe another way, maybe I should have actually, the best thing you should have to say first, the file themselves, because here you have to have the. So let me just redraw this a bit. Actually, this the actually even when if we can end here at this point, it's still, I think I'll have made my point. If you can even end here, I'll have made my point. So here the file here was music.txt, and then here there is jazz.txt and still also music.txt. But all these other, the only being stored, these names are not being stored somewhere as a storage per se. So I'm just here, maybe I should have put even maybe not really in circles. This is not really being stored as, but the real thing that is being stored here is this. The real thing is the blob, and the blob neo to moja, which was which was 9404. So 9404, that blob is the main thing that is being stored. You see now how Git is saving on space for all these three versions of files, because they have the same thing. It just uses the same blob to store this information. So that's a point that I really wanted to stress. Okay. And the rest of the things now, if you go in, if you make any change, let's say now add another musician in jazz, okay? You can add another person like John Coltrane, okay? And move it to jazz. Okay, and now add jazz and commit it. Okay, now let's look. This is the commit already. You can just go and check the commit. I've copied here. I hope you guys have seen this. The commit. Git also gives you back the commit. Also, you can get it by git log. Same thing. AFA, the same thing. Okay. So git cat file -p. This. You get the tree. Another tree now. It's another tree because it has. No. It's not. I'm sorry. It's not another tree rather. But let's look at the it's sort of another 3 years because it has a different. So if you do git cat file p, that as it as jazz and music. Actually, let's compare those trees just to be sure that it's an. And also another thing about the commit that I didn't mention was there's also parent. Remember the very first commit didn't have a parent. You remember the very first one that we did here. If you guys, when we were just, I was explaining the commit and the author and the whatever, it didn't have this commit. If you go back to it, git cat file. Let me clear this. I go back. Git cat file p. The very first commit didn't have a parent. Do you notice that? But now our last commit and second last, of course, will have a parent. So our last commit, like this. Git cat file p. You can see that it has a parent. Parent is just like the predecessor, the previous one before. So basically, now Git is creating something like an audit trail. It knows for any commit, if you just pick it, it will know where it stays in the history. It knows where it is. It knows the parent, and of course, the one that the next one is the one that is in charge of knowing the parent also. So you don't need to say the child. Once you have a link to the parent, all of them can have. I hope you know what I mean. So if all you need is just a link to the parent. So if I have a commit here, commit 1, and I have a commit 2, it just says who's my parent. I just say my parent is C1. Commit 3, who is my parent? My parent is C2. I don't have to say this one to know its children. So by default now I've already created a Git history. So that's how Git history is created because of that parent link. Okay. So let me just, I know time is really of essence. Let me just look at my notes and see if anything that it's important. But I've actually, the point here was just, if you just if you don't remember anything else, just remember this is the model that we have, and remember the commands: git cat file minus p gets you the details, the details of that, and then you give it the hash. And remember the hash you have to get the full hash from either you can go to the files or you can actually look at the commit. So get the hash from commit. From just even git log, okay? That's all you need. Then okay, good. Another thing that I just want, last thing, I think this is the last one. I keep saying last, but this could be the last one. Huh? And then I'll let you go. I'll open up for questions and then I can let you guys go. I know tomorrow is Monday. So let's look at the thing I'm talking about. If you are a detective, you see that there's a new thing that was added called logs. It wasn't there, but after we've done a number of commits, there's been logs. And if you go to logs here, you can see that it's logging everything that is happening in our system. But this is just an extra. I don't think these are just an extra thing for your audit trailing. If you wanted to recover things from your commit, so if you go to logs, you can see the commits I did. You see? Sorry. Initial this, and even if now for guys when you talk about, let's say I notice that I've put here my password in, let's say by mistake, git. I've done a mistake. Let me do inside music. I've put there my password for what's it called? For Spotify. Maybe my password is Nandaa at Speedy, okay? But 2020 as my Spotify password. By mistake nimeweka kwa music.txt, and actually I've committed it. Maybe it's my added new musician or added Spotify password. Maybe just Spotify password. And may push. Okay. So I do git log. I notice I've done a mistake. Okay. You can see, so not this commit here. So that's the commit. Another mistake. Most of things what we will do, like of course there are other better ways, but I think I don't remember. But I know it's a long way. You have to shred. There's a way you can shred those commits to make sure that the person cannot get back. But let's say I notice, I've made a mistake, so I just do a git reset. Okay. Hard, and I say head 1. So I've done a good thing. So nakuja hapa git log, I see there is no your commit, my Spotify password haiko. I look at my file ya music, there's no password here in by mistake. But look, that commit that commit is still there. I copied there. I hope you saw I copied, but you can still get it somewhere. So only copy. If you do now git cat file minus p, I'll give you that commit, okay? Look. Added Spotify civil. Okay, I go to the tree. Git cat file p, give you the tree. Napata your blob. Now the music blob. Git cat file minus p, give it this, and there you go. Password imeipata. You can see, and you can see that the blob, I hope you guys saw that the blob is just another layer. So every line was taken as a layer, okay? So other than storing, it didn't store Miles Davis again. So you have to reconstruct. You have to get Miles Davis, and the other one you have to take the other blob, the previous blob, with now this Nandaa.ptfile, right? Yeah. So that is it. That's was that the last thing. The logs, okay, the logs may show, and then even the logs also is itakutambua. If you go to the logs, you can see that itakwambia tu, yes, you did added Spotify password, and still you moved back, you reset. But you reset, but it doesn't really matter. Someone can go back to these commits and get the stuff that you did. Yeah. So let me open up for questions, maybe 3 minutes. I know it will take this long. Even I was telling Kadima I wanted to finish for 5 minutes and then so we go home. But I think this is what I really wanted to cover for today. And then the last thing is just to give you those resources that I mentioned. And I think will be good. Hopefully this was all I needed, just for opening eyes only, and then you guys can now go ahead and tinker with this thing whenever you have time. Okay. Copy. I'll just paste in the chat, and then Kadima, maybe you can take it to the various places that we keep our records. So copy link. Any questions? You can just unmute and just go ahead.
Hi, Anthony. We have one question on the comment from Stephen Gitich. He says, what if we use git rebase? Does the log still remain?
Yes. That's a emphatic yes, because everything you do here, everything you do in the whether rebase, merge, any basically this is like a clerk. And this is not like at the Kobaya. It's because Git has to be to keep its integrity. Because once committing is a very important thing. So once you've committed something, it is there for the records, kabisa. So the only thing you can do, some tools that people go now, they can go and try and redo this history. There's a way you can play around with this history to do away with some commits, okay? But actually, maybe to answer this question, but I hope it won't take long again. What rebase normally does is this. So you have your history like this, and you have another like history that is running like this, and then so rebase normally will just combine this depending on which one came first and all that kind of thing. Let's assume there's this here, and then so you see it's just changing the parents and stuff like that, or even it could do something like maybe onto disk. So another rebase could be like discarding these parents and just saying that no, my parent is this one, okay, and then this one says my parent is this one, so that now the history becomes something like this. It goes to this one here, which is this, and then comes to this one here. You see, so the history becomes still linear, but these commits have not gone anywhere. Remember the Git objects, unless you go delete the Git objects, that history is there. You can never take it away, because the Git objects are always there. But you might find it hard to trace the what's it called? Might find it hard to trace which objects are for what. But if you're like a detective, if you know about the project, you'll actually just piece together the evidence. Okay, for lack of a better word. Yeah. Maybe another thing that I just forgot to mention was you can also. I was trying to go over this. Git also the code is open source, of course, and some of these things that I've mentioned, you'll actually see them. You'll see if these are for the Git commit. You'll see what it does. Things like if you've done a bit of C, you'll be able to understand this code. And actually, C is not. But I want to encourage you guys, you can learn a bit of C. Many people used to say, oh, where will I use C? C is still alive and well. So it might be good to learn. There's a nice book by Kennigan and Dennis Ritchie. It's usually called K and R. If you just Google K and R, C, the C programming language, or CPL, I think, TCPL. You can learn about C a bit, just like about, I don't think it's a big book, like 200 or something pages. And then it gets you well with C, just star. So if you see a star, don't worry, like, what is this star? But if you learn, you'll just notice they're not really complex things here. So it uses a lot of pointers but this code, I like that the code, you can really understand what's happening in every code. And it's modular, very, very basic. Everything is in basic functions, so you can be able to. So I wanted just to maybe, for example, pick one of those objects, like a commit, what a commit would be here. So if I do an F12 here, it's just a struct with, you can see a commit has an object, as you saw, and a list of parents. No, not okay, this should be just one parent. I don't think there should be many parents, but one parent, and then maybe tree. So the tree, remember the tree that you saw in a commit? Yeah, so basically you can be able, with this, you can be able to, at least, if you look at this code, you at least get to know what's happening in some of these things. Is there a reason why hooks are not pushed to a remote repository, or why they are local to system in use? Yeah, good question. Good question. I don't know. I don't know that I could. If I gave you an answer, I'll just be guessing. Maybe just sort of by seeing what it does, because Git was meant to be. Remember, Git was meant to be. Maybe actually the answer could be maybe part of this. Whatever we learned today. Today we said that the central piece of Git is what is this objects. That's the central piece of Git. Everything else is just the extra things. But object is the central piece. So anything like hooks, branches, all these things will not be central to your code and all that. So that's the reason why perhaps they're not like tracked now in a remote, because now many people will have their own versions. Like in my repo, I'll have my own branches. If I was to push all the branches, we'll have conflict, and we'll have to the central repository, we'll have conflicts. So, but of course, tools like GitHub, they make fancy of, like, you can push the branches if you want. You can pull the other branches from the remote and merge with your branches and stuff like that. But the reason is because this objects directory is the central piece. The rest are just the logs, the branches, the hooks are just extra things. Thank you. I think I can end here. Any other question? I think, guys, I'll also be checking the WhatsApp group. If any question comes up, we can discuss. Some of these things we can find answers together. And really appreciate it. Thank you so much for listening in. And maybe just extra, just to as an outdraw, just say that I'm really like challenged by how you guys are really committed to learning. Like every Sunday you meet like late. Normally I don't want even my Sunday afternoons to be disrupted, but you guys do even up to Sunday evenings, which is really awesome. Just want to say keep it up. I also try to be active and be coming to listen in whichever, because I think I can make it to that time. Yeah, appreciate it. Thank you so much. I'll take it back to Davis. I think Davis was the moderator.
Hi guys, thanks a lot, Anthony. Thanks. It was a very nice session. We were all learning a lot from it. So there was just some questions like, this recording will be shared on the group, WhatsApp group, and also on our LinkedIn. group. Normally our sessions are recorded, and on my comments I've also shared some the links to the WhatsApp group. But thanks a lot, Anthony, for deciding. Yeah, it's true. Sundays normally it's very hard for people to decide to sacrifice, and we really appreciate that you had sacrificed to decided to make us learn a lot on Git. So 1 second, I wanted to share my slide for the community. Okay, Sam is back. So we did the icebreaker and a nice session from you guys can see on my side, on your side, yeah.
Yes, we can
Yeah.
see.
Sure. So we just wanted to highlight that it's a community. Community means everyone can participate in a lot of ways, and things that you guys, and it as a community it always runs by everyone, from us who the behind, in terms of scheduling events and everything, plus everyone who is joining these sessions. So people can be able to help us in running workshops, talks. If you want to participate in coming up with topics and coming up with sessions, if you would like to facilitate sessions or events, you can always reach out in the WhatsApp group. We have our team, an amazing team behind this, and on the group I'll also share the team in terms of names and contacts so that we can contact them, and everyone who has responsibility, or from the amazing team of program managers who are mostly who are the ones facilitating these sessions, setting up schedules for everyone, for the facilitators, and for the guys who also are willing to facilitate and contribute to these events. Thanks to all, and whoever wants to chip in and uh, facilitate a session, you can always get to us in terms of the WhatsApp group, on also on LinkedIn. I will share after this, in the group, uh, the team behind this community, so that you can always and they are all willing for, if you're there, you can just text them and highlight if you want to chip in any way, from running workshops, talks and topics, also connecting us with DevOps professionals, people who have a great experience in DevOps, and also give us feedback, from on the sessions, on how we can best run the community in a way that everyone will will get some, we call it fight, yeah, and, will gain from the community. So yes, the feedbacks, things that we can improve from the community, sharing ideas on how to make the community better, by including some programs, by including some sessions. We are looking into introducing the mentorship program, which will be getting to get people and guys who have vast experience to help most of our members who are just trying to learn and to join DevOps, in terms of their career. So we will introduce that, and all will be shared on the groups that we normally use to communicate. We have also Discord. We have many things, so we will all share on the groups. And yeah, by also sharing ideas on how to make the community better, sharing our posts on social medias, we can reach out to you, and you guys can help us to reach out to other people, you know. Also documenting activities, you know, reminding us, and all sort of things. Yeah, and I've mentioned also organizing events. If you would like to be part of this, just chip in. You can. You will always be, we are open. You can text everyone. I will share the team behind this community. You know, Sam and the other. You can always reach out, and we will plan. So I've shared our WhatsApp link on the comment. And our Twitter handle, it's Nairobi DevOps, LinkedIn Nairobi DevOps community. Yeah. Thanks everyone for sacrificing your evening and joining us in learning. We've done our QA session and many more. If you want to add, you can always text on the WhatsApp. Anton is there, he will answer, and anyone else who is there also will answer and help in case you guys are stuck. So thanks a lot. Good night, everyone.
All right. Bye bye. Thank you.